So I'm not sure what happened with that meeting, but I couldn't get this to load, so we'll just do it from here. So this is exponents, some basic stuff for exponents here. We'll go over this here. When you look at this, you have a base and then you have a power. So here I would have my base. That's a horrible example to start with, but let's go with this one instead. My base here is going to be -3. Okay, so my base is going to be -3 because that's the base there. And then I say there's 1, 2, 3, 4, 5 of them. So the whole thing is the power of 5. This one here is a bad example because the base and the exponent are both 3. But the base is this, whatever you see, and the exponent is how many times you see it. Okay, and then that's how you write as a power. We'll talk more about how that works later. Evaluating each power, let's hold off on this because that's kind of what we're going to do next. It's really the next lesson. So the main part here, forget about quadratics. Let's talk about the exponent rules. So the rules are you have your base and your exponent. So here is your base 3, your exponent is 4, and we call this the entire thing the power. But we don't really talk about this much. We talk more about the base and the exponent. And what this means, so 3 to the 4 is this. You can throw this in a calculator and get your answer. You're looking for this key on your calculator. So you take some time and either find that one or this one. Or some of you have this thing, this upside down V. I call hat. Looks like a hat, kind of. I could do some of my great math art, but I don't like to show off, so I won't. So that you're looking for this, and you'll hit 3, then one of these buttons, and then 4, and get 81. So you can practice that. Pause the video, try that. So that goes. If not, what you can do is expand and say 6 cubed is 6 times 6 times 6, and throw that in a calculator and get your answer that way. So you always have your calculator. We'll talk about the powers in a second. We'll get back to this after. If you have a negative number, there's 2 different types of questions with negative numbers. One is where you have a bracket, and one is where you don't. If you don't have a bracket, your answer is always negative. So if I have this here and I say this is the negative of 3 squared, what you do is you find out this value, just throw it in a calculator, 3 squared, and then you make a negative because it's the negative of whatever. So if I had this negative of 7 squared, you would say that's the negative of 7 times 7. 7 times 7 is 49, so my answer is -49. Okay, this one's different. This is -3 squared. So this is the base in this case is -3. Base over here is just 3. The base is -3. So what you're doing is you're going -3 times -3, and you're getting 9. Now, where it gets interesting is the sign here can be positive or negative depending on if the exponent is even or odd. If you notice the first one, we have 2 here, and 2 is even, so I'm going to have 2 negatives, so this becomes plus. If I had 3 negatives, so -3 times -3 times -3, forget about the number, just look at the sign. Negative times a negative is positive times a negative is negative. So here you'd have -27. Okay, so that's the difference here between a negative in front of the number and a negative as part of the base. So if you have the base, the sign can change back and forth depending on if it's even or odd. Okay. This one here, the reason this is important is your calculator probably won't do this properly for you. So be careful. You can always get this one as negative, but this one here, there's a really good chance you always get a negative answer. Actually, no, that's not true. You'll probably get a positive answer. I don't know. Your calculator probably can't do it, okay? It will give you the same sign, either negative or positive every time, and you're gonna have to figure out the sign yourself. If your calculator can handle this, if you can throw this in your calculator and get -27, then you're fine. You don't have to know the little rules here, okay? But if not, just go ahead, like if you get 27 here, actually do this. If you put -3 squared in and get plus 9, and then you throw in -3 cubed and you get -27, then you're fine. If you have the wrong sign for one of these, then you're gonna have to remember this rule, okay? Other rules, there are 3 other rules. This one is not a rule, really. This is if you have different powers, if you have things and you want to add them, adding doesn't really go with this. So let's ignore that. Let's look at this, multiplying powers. If I have something to the power of something and that same base to the power of something else, what I do is I add the bases. So I have a to the m times a to the n is equal to a to the m plus n. So that seems confusing. So let's just use a real example here. X squared and x cubed. To get the power here, you add them up. And the reason that is x squared is x times x cubed is x, and now I have 1, 2, 3, 4, 5. I have 5 of them here. Okay, so we're just cleaning that up. Okay, it's just another way to write it, and that is what we call the multiplying powers rule. If you divide, you can probably guess, you subtract. So if I divide here x to the 7 divided by x to the 4, I take the 7 and the 4 and I subtract to get 3. Again, the reason for that is if I have x to the 7, it's going to take a while, 4, 5, 6, 7, divided by x to the 4. What I could do here is actually cross these out, cancel these guys out, right? Cancel top, bottom, and I cancel 4 from the top, all the 4 on the bottom, and I'm left with 3 here, and that's how I end up with the 6, 3. So when you multiply, you add the powers. When you divide, you subtract. And when there's a power of a power, you multiply. Okay, so what that is saying is if I have x to the 4 all cubed, it's x to the 4 times 3, which is 12. Okay, and again, if I showed you that, I could show you that x squared cubed, which is x squared times x squared times x squared, right? But each x, so that's really this, right? X times x cubed, which is really x times x times x times x times x times x, right? I got 3 of these guys. There's 1, there's 2, there's 3, and there's 6 again. Okay, and then there's some other rules here, but let's get to those. Well, actually no. So if there's a fraction, let's look at this. If there's a fraction, so we can do this with variables. You can also do it with numbers. If I had here, let's look at examples with numbers. If I had 2 squared times 3, 2 squared times 2 cubed, what's that answer? It'd be 2 to the power of 5. Now I made a mistake there when I started this. If I don't have the same base, I can't do anything. So if I have 2 squared times 3 cubed, that's just 2 squared, whatever that is, times 3 cubed, whatever that is. But you can't clean those up. They don't simplify. Same with variables. If I have x to the 6 divided by y to the 7, that's just that. You can't keep going with that. Okay. But if I have a base, let's say I have this 4 to the 5 divided by 4 to the 4, and notice that division can be as a fraction or can be with a division sign. They both are the same. What I do is 5 subtract 4 is 1, so I have 4 to the 1, and 4 to the 1 is 4. Okay, so that's that rule there. Some other things are if you have two things like this, 2x all squared, you're going to square both the 2 and the x. So this would be 2 squared, which is 4, x squared, which is x to the squared. Okay, if you have a fraction, like 3/2 to the power of 2, what you're going to do is take this power and apply it to both numerator and the denominator. Okay, so it's 3 squared and 2 squared. And if you think about that, that is 3 squared, 3 over 2 squared is really 3 over 2 times 3 over 2, which would be 3 times 3, 9, 2 times 2, 4. Let's say you get that. Okay, and those are other examples here. Okay, other examples that go with this. So those are the rules. And what I'm going to get you to do is not do the earthquakes thing yet. Okay, we'll worry about the earthquakes later. It's not important. And what I want you to do is try the simplifying and try these questions here. And then what I'll do is we can take these up on Friday. So there are a number of questions. Don't bother with earthquake question. And that'll take us to 0 and negative exponents. Don't do that. If you want to read ahead, you can. Okay. But what we're going to do here is we're going to go through this. So let me just do a couple examples here. This will be 4 to the 1, 2, 3, 4, 5, 6. Okay. And then to evaluate this, that means throw it into a calculator. So you would go ahead and throw that into a calculator. This guy here would be minus 3 cubed. Okay. And that would then be negative 3 times negative 3 times negative 3, which is, like I showed earlier, minus 27. 3/5 times 3/5 would be 3/5 squared, which would be 3 squared, 9 over 5 squared, 25. Okay, this one, just throw in a calculator. This one, be careful. Again, because it's to the 3, which is odd, you're going to get a negative answer. Okay, this one here, same rule here. Okay, it's negative 2 cubed over 3 cubed. So again, this will be negative because that's odd. And it'll be 2 cubed, which is 8, over 3 cubed, which is 27. So the final answer is negative 8 over 27. So the negative can be in the top or out front. It doesn't matter. This one here, when you do adding and subtraction, They're kind of silly questions, but what happens is find out what this is, and add them together. So for example, if I did this one, that is 32, and that is 16. Okay, but you can't do anything magical about this. Okay, don't try to do anything when you add or subtract. The bases aren't the same, but that doesn't matter anyway. Adding and subtraction, you can't do anything special. Just find out what that is, and then just figure it out. Okay, so 32 and 16. With expressions, same thing. You have x, you're going to multiply, so you add. This one here, everything to the 2, so this would be 2 squared, x squared, y squared. This one here is going to be 2, all this here, and then you're multiplying. So the 2 stays as a 2, x times x is x squared, y times y is y squared. And don't think we broke any rules here. These are all to the power of 1, right? If I write x, it's x to the 1. So when I multiply, I'm going to add the 1 and the 1 to get the 2. I'm going to add the 1 and the 1 to get the 2 here. Okay, ignore that one. That's silly. This one here, you can do this one. Okay, it's multiply, so you add those two, and then it's subtract, so then you subtract it. And no matter how you do it, you can do it in 1 step or 2 steps or whatever you want. You end up with y squared. All right, so work on this stuff. I'll meet you Friday. We'll take this stuff up. Okay?